So this was more or less all about SVMs. So you saw that we started from the very basic and from the scratch of a support vector machines, and then we saw that how what are the different components of a support vector machines and how each component basically plays a role in classifying linear data. And then after discussing the linear data, we discussed the case of non-linear, in which we saw that we use different kernel functions, in which we, with the help of those kernel functions, we are basically able to classify non-linear data as well with the help of support vector machines. So now again we can have a question that why we need support vector machines, or what are the importance of a support vector machine in different applications. So we can say that support vector machines can be used to solve the data points that are not linearly separable, right? So it can solve both kind of problems, either it is linear separable or it is non-linear separable, right? So support vector machine has the ability to classify data points from both of these categories, effective in a higher dimension. So if even if we increase the dimension of data from a low dimensional space to a higher dimensional space, we saw that support vector machines can be work very effectively and efficiently even in the higher dimensions. Number third point is that it is suitable for small data sets, effective when the number of features is more than training examples, right? So you saw that even in the neural networks, in which we try to learn the algorithm through some training data, but we saw that even in neural networks we need to have some amount of data on which we could train our algorithm, right? But the good thing about SVM is that they are even suitable to perform classification even if we don't have that much of data. So for a small data set problem, SVMs can be effectively used when the number of features is more than the training examples. Also, if we talk about the overfitting problem, right, and I hope you remember that what a overfitting problem is, that in which our algorithms give good performance on the training data set, but when it comes to the unseen data set or the test data set, then in that case our algorithm starts dropping its accuracy, and then we say that it is becoming an overfitting problem. So in overfitting problem, the hyperplane is affected by only the support vectors, thus SVM are not robust to the outliners or outliers, right? So we also saw this with the help of an example, that how our SVM is not robust to when we have different kinds of outliers present in our data set. So this was all about support vector machines. I will recommend you to go through all these slides again from the very beginning till the end, and try to understand each and every concept. And if you have any questions related to support vector machines, then you can ask me in the QA session as well. So from these support vector machines, we will now move on to our next domain, which is basically the unsupervised learning domain, or we can say that it is the clustering problem, right? So in this small lecture slides, I will try to explain that what a clustering problem is, how we can perform clustering in an unsupervised learning domain, and how an unsupervised learning problem or a clustering problem is different from a supervised learning problem. And from this you will have the ability to decide that under what circumstances or for which problems you need to go for classification or for supervised learning domain, and for which problems you need to go for clustering or for unsupervised learning domain. So now let's have a look at this new domain, which is unsupervised learning domain and clustering. So here are some basic definitions of clustering and unsupervised learning domain. We can say that clustering is a type of unsupervised machine learning, right? So in unsupervised machine learning, we will always be, or most of the time, be using clustering. It is distinguished from supervised learning by the fact that there is not a prior output, that is no labels or target data, right? So that the main thing or the key point which is basically distinguishing an unsupervised learning domain from a supervised learning domain is that we don't have a prior output, right? Or we don't have the labels of the data set, right? So this is basically the biggest difference. And when we have this kind of situation in which we don't have an a priori output or the labeling of the data, then we tend to move towards the clustering domain or problem. The task is to learn the classification slash grouping from the data, right? So in clustering, our target is to perform the grouping of the data, right? We want to make clusters of data, and that clustering is basically being learned from the data itself. Sorry. A cluster is a collection of objects which are similar in some way, right? So this is very important, that in clustering we are trying to make clusters of data or clusters of objects, and we will form a collection of objects, right? And those objects which are forming one cluster, those objects will have some parameters or some characteristics which are very similar to each other, right? So we will be looking for some patterns or for some features or some characteristics in different objects, and the objects which have similar characteristics in some way, we will make them in one cluster. And on the other hand, there will be some other objects which will have some other characteristics, and we will form another cluster for that, right? So the basic goal or task is to form a cluster or a collection of objects which are similar in some way. Clustering is the process of grouping similar objects into groups, right? So in each cluster, we are trying to form a group of objects which have similar characteristics or have similar attributes, and we are trying to form a group of them. For example, a group of people clustered based on their height and weight, right? So what we can do is, let's suppose I have different number of people available in my data set, and some people have different heights and some people have different weights, right? So I can make two different groups. One group can be on the basis of height, right? And for another group can be on the basis of weight. So the people who have similar height, we can make one cluster or one group of them, and the people who have similar weight, we can have another cluster or another group of that. So in this way, we can form multiple clusters or multiple groups based on a single common attribute. Normally, clusters are created using distance measure. So a typical way, which we will also be seeing in detail, that in order to form a cluster, or in order to form similar attributes, parameters or characteristics of different objects, in order to form clusters of them, we use a common scale which is a distance measure, right? So we basically calculate distances between different objects, and on the basis of those distances or distance measures, we form different groups or clusters. Two or more objects belong to the same cluster if they are close according to a given distance. So what we are doing is, in calculating the distance measure, is that if the two objects have a closer distance, right? If they are close to each other, it means that they will have minimum distance, and if they are close to each other, then we tend to form a cluster for those objects. In this case, geometrical distance like Euclidean or Manhattan distance. So for these distances, we usually use two different types of distance measures, in which one is a Euclidean and one is a Manhattan distance. I hope that most of you are already familiar with the different kinds of distance measures, but we will also see their formula in detail in the later slides. Another measure is conceptual. So another measure which can be used to form groups or clusters can be a conceptual way. Two or more objects belong to the same cluster if this one defines a concept common to all that objects, right? So if there is a one common concept which can group multiple objects, so we can use that concept in order to form clusters. In other words, objects are grouped according to their fit to descriptive concepts, right? So we will have a conceptual mechanism or a conceptual way, and we will see that which objects are basically being fitted to that concept, and on the basis of that we can also create groups or clusters.